Hello, audience from MedInfo 2021. I'm Jiaxin Liu from Zhongnan University of Economics and Law in China. Today, I'm here to talk about our recent work on automatic patient fall outcome extraction using narrative incident reports. This is a collaborated work with Zoe Sun-Yi Wang from St. Luke's International University in Japan and H.Y. So from Alice Ho Miu Lin Nasal Hospital in Hong Kong SAR. Well, as is known, incident report is a good way to record the patient safety incident and enable analysis and learning. WHO has proposed an information model called MinPS framework to achieve information sharing and lessons learning worldwide. It defines the minimal information should be recorded during incident reporting. In the latest version of MinPS, there are two major parts in this model, structure part and the free text part. As we can see in the structure part, incident outcome is one of the key information categories in incident reporting. It consists of patient outcome and organizational outcomes. Reporting patient outcomes will allow for a better analysis of the direct consequences to the patient. We focus on patient outcome in this study. However, patient outcomes may not fully registered in the structure part in many reporting systems. Key characteristics of patient outcomes, such as injury-related information, normally was described in the free text, but not recorded as structured features. This will make post-incident analysis less efficient. Therefore, we hope to extract the injury-related information from the free text part to better describe the patient outcome. The first objective of this work is to automate the extraction of patient outcomes using incident reports. In this work, we first focus on the 4 incident reports. In order to achieve the automatically extraction of patient outcomes, we break it into 3 subtasks, including the identification of whether any injury was sustained, the identification what kind of injury was sustained, and identify how many injury was sustained. These questions are of great interest when analyzing patient outcomes in 4 incidents report. The above task can be transformed to classification problems in the context of machine learning, and one of our published incident report classification framework shall be in use. So here comes to our second objective, is to internally validate the published IRC framework through the application in patient outcome classification. Here I would like to introduce the data we have in this study for analysis first. We obtained in-hospital 4 incidents reports in Hong Kong from January 2011 to September 2014. The data was collected by Advanced Incident Reporting System, AIRS, from 7 public hospitals in Hong Kong. The free text part was written in English, and the reason why we use the AIRS incident reports to carry out this patient outcome extraction task because unlike most incident report systems in the world, AIRS capture injury types in both a structured and unstructured manner, allowing us to develop the patient outcome extraction models and then examine the model performance. Before further analysis, we first perform quality screening and the identification for the reports. And finally, we extracted 1,222 for incident reports. We can observe that around 90.5% reports presented injury sustained, and only 4.4% of all cases sustained multiple injuries. There are 7 injury types registered in the AIRS system. dislocation, hematoma, abrasion, bruising, fracture, dislocation, and others. Since there is only one dislocation case, it would be hard to learn from it by the model, and there could be multiple actual injury types in others type. So we focus on the extraction of the 5 injury types marked in the red here in this study. As is mentioned, we have 3 subtexts in this study. Subtext 1 identify the presence of injury. This is actually a binary classification problem. Subtext 2 identify whether there is a specific injury type mentioned in the report. So actually there are 5 binary classification problems in this subtask 2. Subtask 3 actually is a multi-class classification problem. It has 3 classes, no injury, single injury, and multiple injuries. For this classification problem, we intend to use the IRC framework. We published this work in JAMA in 2021. So the whole IRC framework was originally designed for multi-class classification for severity level, but we believe it remains effective in the new problem and the binary classification problems. So here I will illustrate in detail about the IRC framework. In order to train up the classification system, we will first separate the incident report database into 80% and 20%. 80% is for training and the validation dataset, and 20% is holdout for testing and for testing. So for the training and validation dataset, we will extract the free text and the clinical information separately. We will perform standard text preprocessing techniques to the narrative text and extract back of words features and structured text features. As for the clinical information stored in the system, we will perform data imputation as preprocessing steps and also extract the structured clinical features. We will describe the what are the structured features are in the next slide. And here are the detailed description of the structured features in the IRC framework. It mainly consists of structured text features and structured clinical features. Structured text feature mainly includes the word counts and the sentence counts in the free text part. And the structured clinical features mainly include the patient demographic and the incident date, time. These structural features may help us to classify better in the incident reporting system. Now that's back to the IRC framework. For the back of words feature, we also consider the different weighting scheme, including binary, TF-IDF, and term frequency. After feature extraction, we will apply the resampling methods to rebalance the data. Since we observed the class imbalance problems in all these 3 subtasks. For example, in subtask 1, the presence of injury only exists around 20% of all the incidents reports. Therefore, this is a class imbalance problem. Here we will apply the random oversampling methods. This is the best performed resampling methods found in the JAMA work. After apply the resampling methods, we will apply the machine classifiers to perform the classification. We will consider 3 options, including naive Bayes, SVM, and a random forest. After this, we will perform the model selection by 5-fold cross validation. We will make a choice of the back of words feature representation scheme, make a choice about the machine learning classifiers and the two other parameters in the classifiers. And this will, in the end, yield an optimal classification system. At last, we will test the optimal classification using the 20% testing data set. In the end, we will repeat the whole process for 4 times to prevent the training and the validation data set and the testing data sets extreme splitting. And we will report the average performance for model evaluation. Here are the evaluation metrics used in this study for binary classification, like subtext 1 and subtext 2. We will use precision recall and the F1 measure and the area under the receiver operating characteristic curve as the measurement of the performance. And for multi-class classification, like the subtext 3, for each class, we will compute the precision and the recall and the F1 measure. Also, we will derive the macro average, the precision, recall, and the F1 measures for overall performance evaluation. There was 2 special settings in the IRC framework. One is the incorporation of resampling methods. Another is the incorporation of structural features. Therefore, in order to further validate the IRC framework, we also compare it with the baseline system, which performs without the structural features and resampling methods. We will show the result from these 2 different classification system settings and compare them. Here comes the result. For subtext 1, the identification of the presence of injury. Compared to the baseline, and the IRC framework improves the overall performance for around 4 to 5% in terms of F1 score and AUC score. And for this task, it achieved around 0.9 F1 score and 0.943 for AUC score. The better performance was mostly achieved by a better recall compared to the baseline and with minimal sacrifices on the precision. For subtext 2, the identification of injury types, we presented the results of all the 5 binary classification tasks. We can see here IR3 has improved the overall performance in terms of F1 measures and AUC ROC for the identification task for all injury types compared to the baseline. For subtext 3, the identification of number of injuries. This is a multi-class classification. Also, the IRC framework has achieved improved performance compared to the baseline, especially for the micro-averaged metrics. They all improved from 5% to 12% compared to the baseline. Now, here comes to the discussion. From the competitive result, we found that automating for patient outcomes extraction from the incident reports is possible using the IRC framework, and the improved results compared to the baseline further validated the IRC framework's superior power in handling imbalanced data issues in both binary and multi-class classification tasks. And maybe multi-label classification may warrant further investigation on how it performs on identifying multiple injuries. Thank you all for listening today. Should you have any question about this talk, please feel free to contact us.